Hello, this is Mr. Stansbury. I'm going to take you through the 15 e-notes on implications. At the end of this, you should be able to say that I can write an implication, and also I can determine if statements are equivalent or not. Okay, so first thing, implication is a compound statement formed using if and then statements. Okay, so for example, if P then Q is written P, and then you got the arrow here pointing to Q. Okay, and you could also write that as P implies Q. Okay, that's another way that you will see that written. All right. Example. Excuse me. Show the truth table for the implication P implies Q, where P is if I have all the proper ingredients, and then we have Q is then I can make the best cookies. Okay, so let's make a little truth table for this. So remember, when we are making a truth table, we start with the last implication. We go true, false, and then the next implication over we double the trues and doubles the falses. So true, false, and we are good to go. So we want to figure out P implies Q. So P implies Q. Okay. I'm showing you this example because I used this in classes in the past, and this really seems to help out with implications because, again, this is all logic, and logic can get pretty confusing at times. So this example here seems to have cleared a lot of things up for some people. So with that, starting with P, does P imply Q? So P is if I have all the proper ingredients, that's true, and then I make the best cookies, that's also true. So if I have all the proper ingredients and I make the best cookies, you can assume that that's true because P would imply Q because I have all the best ingredients and I make the best cookies. Now, if I have all the best ingredients and I don't make the best cookies, you can assume that that is not true because I had my opportunity, I had everything I needed, but I messed up and I made rotten cookies. So that would be false. Now here's the weird part. Okay, so if I don't have the ingredients, you can't prove whether or not I can make the best cookies or not. So you just have to assume that it's true. So if I don't have the best ingredients, we don't even care what this says over here. If I don't have the ingredients, you have to assume that this implication is true. Okay? So same thing here. If I don't have the ingredients, you have to assume that this is true. So this is the implication for these two statements for P implies Q. Okay? So it would be true, false, true, true. Again, if you get falses in the first statement, you just have to assume that they're going to be true because you can't disprove it because you don't have the information. That's the way I like to look at it, and it really kind of helped clear a lot of things up with this. Okay? All right. With that, actually, let's leave that up there for a second, and let's take a little video break. Let you kind of chew on that stuff for a bit.
Nah. I don't know who's writing books for babies, but I want a piece of that financial pie. I put my daughter on my lap with this big cardboard book, The Clock. The big clock. Tick-tock. The end. $12.
All right. Okay. So that's our implications. Let's look a little farther. Look a little closer at this here. Okay. So with that, we also have in implications we have equivalence. Okay. When one statement applies the other and vice versa, you get this little double arrow, and that's considered equivalence. Okay. So for P, this is an example from page 507. P is I will pass the test. Q is the test is easy. So we'll write down our P implies Q, Q implies P, and then P is equivalent to Q. All right. So P implies Q. I will pass the test. So if it's P implies Q, it's if I pass the test, then the test is easy. So if I pass the test, then the test is easy. If it's Q implies P, we just switch the if and the then statement. So this becomes the if statement, and that's the then. So it's if the test is easy, then I will pass the test. So if the test is easy, then I will pass the test. So P implies Q is I will pass the test if and only if the test is easy. Okay, so that will imply both back and forth. Okay, so that's the if and only if is our equivalence statement. Okay, so let's take a look at the truth table for this. Okay, so we've got P and Q. So again, start with the second one, true, false, and then we got true, false, false. So now we have P implies Q. Okay, so remember, if it's true, then that's going to be true. Again, I always go back to the cookies and the ingredients. I have the ingredients, I can make the best cookies, so that's got to be true. If I have the ingredients and I can't make the best cookies, then that's got to be false. If I don't have the ingredients at all, like these last two, I can't disprove anything, so I have to assume that it's true. Okay? So, Q implies P. Now we're going to go the other direction. So, I have the ingredients. So this is the ingredients column. This is the make the best cookies. So true and true, that would be true. I don't have the ingredients, so I can't assume. I have to assume that you can make everything great, so that's going to be true. I have the ingredients, but I can't make the best cookies. This is the false, and that's the only one, is where you get the false in there, is if you start with true and you end with false. That's the only false in there. And then again, I don't have the ingredients, so again, I have to assume that it's true. All right, so P implies Q is where you get P. So this really is the same thing as P implies Q and Q implies P. So we want to know when these two are both true. Okay, so it's got to be and. So P implies Q and Q implies P. So true. So since they are both true, that's true. Only one of these is true, so that would be false. Only one of these is true, so that would also be false. And again, these are both true, so this has to be true. So this is kind of the long way about getting it. But so P implies Q and Q implies P is this here, and again, that's where both of these have to, P has to imply Q and Q has to imply P. So again, this is the equivalence statement. Okay, and it's P if and only if Q. Okay, a little bit easier way to figure that out here is if you'll notice these statements are the same, these are different, and then these statements here are the same. And the two where the statements are the same are the two true statements, and the two where the statements are opposites are the two false statements. So that's kind of a little different way to look at that. Okay. So 15E, implications. You should now be able to say that I can write an implication, and also I can determine if statements are equivalent or not. Okay. If you have questions, please ask in class. All right. Thank you.